Welcome to the deep dive. Today, we're really digging into one of the biggest strategic choices facing companies right now, especially with AI just exploding everywhere.
Yeah, it's a huge one.
It's this fundamental question right at the heart of using AI effectively. When you need AI tools, AI infrastructure, your whole AI stack, do you build it all yourself? Or do you just buy it off the shelf, plugging into what others have built?
And it sounds like just a tech decision, maybe for the engineers,
Mm-hmm.
but it's really not.
No, not at all.
It's a core strategic fork in the road. Technical leaders, product managers,
Mm-hmm.
even the CEO, they're all grappling with this.
Yeah.
What you choose impacts, well, everything.
Like what specifically?
Your speed, for one.
Yeah.
How fast can you get AI features out?
Huh?
Also, control. How much command do you have over the tech, the data? Then there's cost, obviously upfront versus long-term. And resilience. How future-proof are you? How competitive?
Exactly. So our mission in this deep dive is to unpack all that complexity. We want to get really granular on the specific build versus buy decision for AI. We'll weigh those factors you mentioned: cost, control, performance, flexibility, as things change, which they always do in AI.
Right. And we're pulling all this from a deep look into source materials we've gathered, articles, research papers, analysis, all focused specifically on this AI stack, build versus buy strategy.
Think of it as us trying to, filter out the key insights from all the noise out there. Because this topic, it's dense, it's moving incredibly fast.
Absolutely. The sources really map out the different options available now and the pretty profound consequences of choosing one path over another. It's crucial stuff, whether you're leading a tech team, maybe building a product using AI.
Or even if you're an investor looking at companies in this space.
Exactly. Or just, curious about the choices behind the AI tools you might be using every single day without even realizing it.
Okay, let's tackle that core dilemma head on then. The source material frames it really clearly as this strategic crossroads. Path one, build it yourself.
Right. And that can mean a lot of things. It could involve actually training your own big foundation models from scratch, though.
No.
It's
Yeah.
rare, super expensive. More commonly, maybe it means taking open source models and fine-tuning them, hosting them yourself.
And managing all the complicated infrastructure needed to run them properly.
Exactly. The servers, the GPUs, the whole MLOps pipeline. That's the build path.
And path two, the alternative.
That's the buy path. Usually, this means using fully managed services, typically through APIs from the big AI labs. OpenAI, Anthropic, Google, folks like that.
So you're basically just plugging into their models, sending data, getting results back.
Precisely. You don't run the model, you just consume its output as a service.
Yeah.
Like renting intelligence almost.
And the sources really hammer this home. It's not like picking database A over database B. This is fundamental. It shapes your whole company, right?
Totally. It determines who you hire. Do you need deep ML researchers or just engineers who can integrate APIs? What kind of operational know-how do you need? How do you handle data privacy? And maybe most importantly, how unique or defensible is your product? Can someone else just plug into the same API and copy you?
Wow. Okay, so the AI stack itself, it's not just one thing anymore.
No, not at all. That's a key point from the sources. It's become really layered, modular. There's a whole spectrum of options now, from pure buy at one end to pure build at the other, with lots of points in between.
Understanding those layers is critical then to making the right call for what you need.
Definitely. You need to know what's actually on the table today.
Okay, so let's break down those options based on the source material. Starting at the pure buy end, what's the simplest form?
That's using those fully managed APIs we mentioned. Consuming AI like a utility. You send your data, maybe text for summarization or an image for description, specify the task, and boom, the provider's massive infrastructure does the work and sends back the results.
And you don't touch the model, the hardware, nothing.
Nope. It's all behind the curtain. Minimal technical lift for you. Just integrating the API call into your code.
Okay, seems easy enough. What's the next step? Maybe a little closer to build.
That would probably be fine-tuning foundation models. This is super popular right now, kind of a hybrid approach.
How does that work?
You start with one of those big, powerful foundation models, like a GPT model or something similar, that's already been trained on tons of general internet data. You don't train that base model yourself. That costs fortunes.
Right, hundreds of millions. Maybe.
Easily. So you take that existing generalist model, and then you train it just a bit more using your own specific domain-relevant data.
Ah, so you're leveraging its general smarts, but teaching it to be an expert in your specific area? Using your company's data, perhaps?
Exactly. You're adapting it. Maybe fine-tune it on your internal knowledge base so it can answer employee questions better, or on thousands of your customer support tickets so it understands your common issues perfectly.
So you get more customization than a generic API, but you're still kind of building on top of something you bought or licensed.
Precisely. You're often using a platform provided by the model creator or a third party to do the fine-tuning. So there's still some reliance there.
Got it. What's next on the spectrum towards build?
Okay, now we're talking about self-hosting open source models. Think models like Llama from Meta or Mistral or others where the model weights, the actual parameters, are publicly released.
So instead of sending data out to OpenAI's API.
Right. You download the model files yourself, and you run them on your own servers. Could be in your own data center or in your private cloud setup like on AWS or Azure, but within your controlled environment.
Okay, that sounds like a big jump in responsibility.
Oh, it is. Huge jump. You gain a ton more control over how it runs, the latency, and crucially, your data never has to leave your building, so to speak, when you're using the model.
Big plus for privacy.
Massive. But now you own the whole operational headache. Setting up the GPUs, managing the software, making sure it's reliable, scaling it up if you get more users.
Yeah.
It's a serious undertaking.
You're the one getting paged if it breaks at 3 a.m.
You got it. And then, the furthest end, the pure build extreme.
What does that look like?
That's building custom training pipelines. This is the deep end. It could mean designing and training a model completely from scratch with your own unique architecture and massive data sets. Or maybe taking an open source model and radically changing its structure and how it's trained.
This sounds like serious AI research territory, like what the big labs do, needing huge data sets, massive compute clusters.
Exactly. This is usually only for companies where the AI model itself is the core product, the main innovation. It requires fundamental breakthroughs at the model level. Very, very resource intensive.
Okay. And the source also mentioned other pieces of the puzzle, right? Things that aren't the model itself, but support it, like platform abstraction layers.
Yeah, those are important too. Tools like LangChain or Llama Index, they help developers build applications on top of these language models, whether they're accessed via API or hosted internally. They help manage complex workflows, like chaining multiple model calls together.
And vector databases. We hear about those constantly now. Pinecone, Weaviate.
Crucial. Vector databases are essential for a technique called retrieval augmented generation, or RAG. That's a really big deal right now.
Oh, Shay. Okay, break that down. How does that fit into build versus buy?
So RAG is a clever way to make AI models much smarter about your specific up-to-date information, stuff they weren't originally trained on, instead of just asking the model a question based on its, potentially outdated general knowledge.
Which might be months or years old.
Right. With RAG, before you ask the model the question, you first retrieve relevant documents or pieces of information from an external knowledge source. Often that source is a vector database because they're super fast at finding information that's semantically similar to your query.
So you search your own database for relevant context first.
Exactly. Then you take that retrieved context, maybe paragraphs from your company's latest policy documents or recent customer reviews, and you feed it to the language model along with the original question.
Ah. So the model isn't just guessing based on its old training data. You're giving it the relevant facts right then and there to base its answer on, like an open book exam.
Precisely. It makes the answers much more accurate, current, and grounded in specific knowledge. And the key point, connecting back to build versus buy, is that you generally need RAG and vector databases regardless of how you access the main language model.
Whether you use GPT-4 via API or run Llama yourself.
Exactly. You still need that system to store, manage, and retrieve your specific knowledge to feed into the model for context. So these tools, VectorDB's RAG frameworks, they complement both the build and the buy strategies at the model layer.
Okay, so the modern AI stack is really this mix and match set of components. Models, databases, orchestration tools, and you're deciding which bits to own and which to rent.
That's a great way to put it. And the source material really boils down the decision pivot point to 3 critical factors: risk, speed, and flexibility.
Risk, speed, flexibility. Explain those.
Okay, risk. How much technical risk, operational risk, data privacy risk, even vendor lock-in risk are you willing or able to handle? Bills means more operational risk. Buy means more vendor risk. Speed. How fast do you absolutely need to get this AI capability out the door and start iterating? Buy is usually faster initially. Flexibility. How much do you need to customize the model's behavior, integrate it deeply, or adapt it over the long term? Build generally offers more flexibility.
So you're constantly trading off between those three.
Exactly. Your specific situation, your priorities regarding risk, speed, and flexibility, that's what should guide your decision across that spectrum of build, buy, or somewhere in between.
That makes a lot of sense. It's not just which tech is cooler, it's about aligning with the business needs. Okay, let's zoom in on the buy strategy first. Using those APIs. What's the big appeal, according to the sources?
The immediate advantages are really strong, especially if you're just starting out or testing an idea. The number one benefit, minimal setup.
Like really easy to get started.
Yeah, often it's just sign up, grab an API key, maybe pip install a library, and you're making calls within minutes or hours.
Yeah.
Compare that to setting up servers, installing complex software, downloading huge model files. It's night and day.
That translates directly to speed, right?
Absolutely. Less engineering time spent on infrastructure means more time spent actually building your product feature, testing the user experience with AI. You can run experiments incredibly quickly.
Validate ideas faster.
Exactly. Another huge plus is getting access to best-in-class performance almost instantly. Companies like OpenAI, Anthropic, Google, they spent billions developing these incredibly powerful models. By using their API, you tap into that state-of-the-art capability right away.
Without needing your own billion-dollar R&D budget and giant AI lab.
Precisely. You leverage their massive investment, and related to that is you get instant updates and scalability, usually. Well, when the provider releases a better, faster, smarter model, you often just change a parameter in your API call to start using it. The improvements come to you. And if your app suddenly goes viral and usage spikes, the provider handles scaling up the back-end infrastructure to meet that demand. You don't have to scramble to add more servers for the AI part.
That operational burden is just handled by them.
Exactly. It's offloaded. Which sounds amazing if speed and simplicity are your top goals.
The source had a good example of this, didn't it? A productivity app using something like GPT-4.
Yeah, a really clear illustration. Imagine a team adding a feature to, say, summarize long email threads or draft replies based on bullet points. Instead of hitting pause on everything else to figure out how to build or fine-tune a language model.
Which could take months.
Right. They just integrate the API, they send the email text, ask for a summary, send the bullet points, ask for a draft. Simple integration.
And the payoff, according to the source.
They launched the feature in weeks instead of months.
Weeks versus months in a fast-moving market, that's huge.
It can be the difference between leading and following. Buying that API access lets them de-risk the core AI tech quickly and focus their engineering effort on the user experience around it. Get it out there, get feedback.
Okay, so the takeaway for the buy side seems pretty clear from the sources. If your main concerns are time to market and keeping the operational complexity low, especially early on,
then buying through APIs is incredibly attractive. It's often the necessary first step. It's why it's the default starting point for so many companies dipping their toes into AI right now.
it's the path of least resistance to get moving.
For sure. But, and it's a big but,
There's always a but.
always, the ease comes with trade-offs. The source material then shifts focus to the, let's call them, the hidden costs and the significant downsides that can emerge if you only rely on bought solutions, especially as your product matures and scales.
Right. It's not always smooth sailing long term. What are the big watchouts?
Number one, often, is vendor lock-in. This is a classic tech problem, but maybe even more acute with AI APIs.
Meaning you get stuck with one provider.
Exactly. If the core intelligence of your product depends entirely on, say, OpenAI's API, you're tied to their technology, their pricing whims, their terms of service, their decisions about which models they support or discontinue.
And switching later, if you want to or need to, is tough.
Can be incredibly difficult and expensive. Your code, your workflows, maybe even your whole product architecture might be designed around the specifics of that one API, ripping it out and plugging in something else. That could be a major re-engineering project.
Okay, lock in. What else?
Cost. Specifically, high usage-based pricing. APIs are usually priced per unit of consumption per token processed, which is kind of like a word or part of a word, or per API call.
Seems cheap when you're just testing with a few calls.
Deceptively cheap.
Right.
But what happens when your AI feature is a hit? Your user base grows, usage skyrockets.
Those per token costs suddenly explode.
Exactly. What was pennies becomes thousands, maybe tens or hundreds of thousands of dollars a month. Your costs scale directly with usage, sometimes even faster if you need more complex models. It can absolutely hammer your profit margins. You don't benefit from economies of scale like you might if you ran it yourself.
I've definitely heard horror stories about unexpected, massive API bills.
It's a very real risk if you don't model it carefully. Then there are performance issues, latency, and region restrictions.
Ah, the speed problem again, but in a different way.
Right, you're sending data across the internet to the provider's server. It does the processing, sends the result back. That round trip takes time. Milliseconds, maybe seconds. For some applications, that delay, that latency, is unacceptable for the user experience.
Like real-time interactions.
Yeah. Plus, you're limited by where the provider physically has their servers. If your users are in Australia, but the model runs in the US, they'll likely see higher latency than users closer to the server. You don't control that geographic placement.
So the initial speed-to-market benefit could be countered by slower performance in production for some users.
It's a trade-off. And a really big one, highlighted in the sources, especially for certain fields, no visibility into model internals.
The black box problem.
Exactly. You send stuff in, you get stuff out, you have zero idea how the model produced that specific output. You can't inspect its reasoning, its weights, its intermediate steps.
Why is that such a big deal? If the answer seems right.
Huge deal in many contexts. What if the answer is subtly wrong or biased? You can't debug it. You can't diagnose why it made a mistake. More importantly, in fields like finance, healthcare, legal, you often need to explain why the AI made a certain recommendation or decision.
For compliance, for user trust.
Both. Try telling a regulator the AI said so, but we don't know why. Or telling a doctor to trust a diagnosis from a system whose reasoning is opaque. It doesn't fly. This lack of explainability is a major blocker for using APIs in high-stakes, regulated, or mission-critical applications. You need transparency.
You need to be able to lift the hood.
Okay.
And then there are the data privacy and legal issues.
Oh yeah, massive ones. Sending your data, potentially sensitive customer data or proprietary company information, to a third-party API provider, that raises huge questions.
Like, what are they doing with it? Is it secure?
Exactly. And crucially, does sending it even comply with regulations like GDPR in Europe, HIPAA for health data in the US, CCPA in California, or specific financial rules? For many companies, the answer is simply no. They cannot let certain data leave their controlled environment. Using an external API for that data is a non-starter.
The sources had that really stark example, didn't they? The legal tech startup.
Yes, that perfectly illustrates how these downsides converge. This startup built a tool using an LLM API for things like summarizing legal documents, drafting arguments. Sounded great
Until
they scaled. First, the API costs ballooned. The source mentioned $50,000 a month just for the LLM call.
$50,000. Wow.
Yeah, serious cash. That's the usage-based pricing hitting hard. But the even bigger problem was the black box issue. Because they use an API, they couldn't explain how the AI generated its summaries or legal drafts.
And lawyers need to know the reasoning, right? They can't just trust a black box.
Precisely. Their clients, legal professionals, started raising red flags. They needed auditability, explainability. They couldn't fully trust the output without understanding the process. So the startup was paying a fortune and losing client trust because the buy approach lacked transparency and couldn't guarantee data control for sensitive legal matters.
So the initial ease turned into a massive long-term liability, costly and damaging to the product's credibility.
Exactly. It shows that while buying gets you started fast, the lack of control, the potential costs, the transparency issues, they become really significant problems as you grow, unless you find ways to mitigate them or, well, regain control.
Which perfectly tees up the other side, the build it path. Let's shift gears. What are the strategic wins you get from building, according to the sources?
The absolute core advantage is control. Deep control. Specifically, the source highlights ownership of the model weights and the data.
Meaning if you train or fine-tune it yourself.
You own the resulting model, its parameters, its brain. And crucially, you maintain full control over your proprietary data that was used to train or customize it. That data, often your most valuable asset, never leaves your control.
That seems fundamental if the AI is part of your secret sauce or uses sensitive info.
Absolutely. This ownership is key for differentiation and data security. And it enables much deeper domain-specific fine-tuning than you can typically get with APIs.
Going beyond basic customization.
Way beyond. Building or deeply fine-tuning lets you train a model precisely on your company's unique language, its specific knowledge base, its particular customer interaction patterns, even its brand voice. You can make it a true expert in your narrow domain.
So not just a generalist model, but one that really gets your business, your industry.
Exactly. Train it on your internal engineering docs, your specific financial reporting standards, your unique medical terminology. This leads directly to tuned performance.
Tuned performance. That means optimizing for speed, cost, and accuracy, all three.
Yes, you get to choose the trade-offs. Need lightning-fast responses. Maybe you optimize a smaller model architecture and run it on specialized hardware you control. Worried about costs at massive scale. Running it yourself despite high upfront hardware costs.
Like buying all those expensive GPUs.
Right. But once that's paid for, the cost per query can become much, much lower than paying API fees, especially if you have millions or billions of queries. The marginal cost drops significantly.
Potentially much cheaper in the long run at high volume.
Potentially, yes. And accuracy, that domain-specific tuning, usually leads to far higher accuracy on your specific tasks compared to a general-purpose model. You control the optimization levers.
You get to dial it in for exactly what you need. And a huge benefit, especially thinking back to the legal tech example, is deployment flexibility, right? On-prem or secure cloud.
This is absolutely critical for many sectors. Building or self-hosting means you can run the model inside your own firewall, in your own data center, or within a tightly controlled virtual private cloud VPC environment.
Meeting those strict security and compliance rules.
Exactly. IP, GDPR, financial regs, whatever applies. Your sensitive data stays within your secure perimeter during processing. It never goes out to a third party.
That's non-negotiable for healthcare, finance, government, lots of areas.
For sure. It maintains that clear chain of custody over the data. The source had that great example. A healthcare company fine-tuning Mistral models.
Right, using an open source model for sensitive patient data.
Exactly. They absolutely cannot send protected health information, PHI, to a standard external API. That's a compliance nightmare. But by taking an open source model like Mistral, which they might be able to understand better than a proprietary black box, and fine-tuning it internally on their own private, perhaps anonymized medical data.
They get the power of AI without breaching IPR.
Precisely. They can use it for internal tasks, maybe research, maybe improving administrative efficiency, maybe even carefully supporting clinical decisions while keeping all that sensitive data safe and compliant within their own systems.
And potentially, at scale, it's cheaper per query than an external API would be for that volume, assuming they made the initial investment.
That's often the case. So the big takeaway here from the source is clear. When your business absolutely requires high precision, or has strict privacy and compliance mandates, or needs deep customization for differentiation, or values platform independence,
Then building, or at least self-hosting and fine-tuning, isn't just an option, it becomes a strategic necessity.
it's driven by the fundamental needs of the business, the data, the industry. The AI becomes a core controlled asset.
And here comes the other big but. Building sounds incredibly hard. The sources are very upfront about the hurdles.
Well, absolutely. This is the crucial reality check. Building is not for everyone. Far from it. The biggest barrier,
Talent.
finding the right people. Finding and affording the right, highly specialized people. The source specifically calls out needing skilled ML engineers, the ones who actually build, train, fine-tune, evaluate the models. Then you need MLOps engineers. This is critical.
MLOps, we hear that term a lot. What exactly do they do, and why are they so key for the build path?
Great question. MLOps is basically DevOps, but for machine learning. These are the engineers who take the model built by the ML team and make it work reliably in the real world, 24/7.
So not just building the model, but running it in production.
Exactly. They build the automated pipelines to deploy new model versions safely. They set up monitoring to watch for problems, like if the model's predictions start getting worse over time. It's called model drift. They manage the infrastructure the models run on, ensure everything is reproducible, handle scaling, security patching, rollbacks if something goes wrong. It's complex operational work.
It sounds like a bridge between the science and the software engineering reality.
That's a perfect way to put it. And finding people with both strong ML and strong operational software skills. Very tough, very expensive. And the source also mentions needing expertise in managing those GPU clusters we talked about.
The specialized hardware for AI.
Right. They're costly, power-hungry, need special cooling, and operating them efficiently at scale is a whole discipline that most standard IT teams don't have experience with.
So it's not just hiring a few data scientists, it's building a whole specialized team and infrastructure capability.
For sure. Which leads straight to the next barrier. You have to own the entire operational burden.
Meaning
When you build, you're on the hook for everything. If the model crashes, if there's a bug, if the servers get overloaded, if there's a security hole, it's your team that has to fix it, day or night. There's no vendor support contract to fall back on. You are the vendor.
you carry the pager.
You carry the pager. And tied to this, the source points out there's no one-click deploy, like with simple software. Getting a complex ML model into production, monitoring it, updating it, it requires building sophisticated deployment pipelines and processes. It's a major ongoing engineering effort, not a simple push-button operation.
That really drives home the complexity. The source had that quote, didn't it? Something like, most companies aren't ready to own models like they own APIs.
Yeah, that hits the nail on the head. It perfectly captures the gap. Integrating an API, that's mostly standard software engineering. Owning the model itself, that requires deep ML knowledge, sophisticated MLOps practices, heavy infrastructure management. It's a fundamentally different game, requiring a much higher level of technical maturity and operational rigor.
Most companies are good at plugging things together, but not necessarily at running the complex engine inside.
Exactly. They have decades of experience consuming services, but maybe only years or months or no experience operating AI models at scale themselves.
So the takeaway on building is pretty stark. It's powerful, yes, but incredibly demanding. Huge investment needed in talent, hardware, process. Requires real organizational readiness and operational muscle. It's not a path to choose lightly.
Definitely not. It's a major strategic commitment, really only feasible for organizations with significant resources and a long-term vision for deep internal AI capability.
Okay. Wow. So we've got fast, easy start, leverages others' R&D, but risks cost explosion, lock-in, lack of control and transparency. Then we've got build. Total control, customization, potential cost savings at scale, compliance-friendly, but incredibly hard, expensive, and requires rare talent and operational excellence. It feels like you're stuck between a rock and a hard place.
It can certainly feel that way if you think it has to be one or the other,
Yep.
exclusively. But this is where the source material offers that really crucial pragmatic insight. It argues that for most companies, the smartest approach isn't strictly either. The reality is, hybrid is the new default.
Hybrid, meaning mixing and matching, not picking just one strategy.
Exactly. The source makes a strong case that the most effective path often is to blend these approaches. You don't need to use the same AI solution for every single task across your entire company or product.
You can be more strategic, use case by use case.
Precisely. Smart companies are tailoring the build-buy decision based on the specific needs of different applications.
So how would that work in practice? Buying for some things, building for others.
Yeah, that's the idea. The source describes common patterns. For instance, a company might use hosted models, those external APIs, for the more generic, less sensitive stuff.
Like what?
Maybe summarizing public web content, drafting initial marketing copy that doesn't use internal secrets, powering an internal chatbot for general company info. Tasks where speed and convenience are key, and the data isn't highly confidential.
Okay, use the easy API route for the low-risk general tasks.
Right. But simultaneously, for the really sensitive workflows.
The ones involving customer data, financial info, regulated processes.
Exactly. For those, they'll run models internally, either fine-tuned open source models or perhaps custom-built ones, running securely on their own infrastructure. This gives them the data privacy, the control, the compliance guarantees they absolutely need for that critical subset of tasks.
So you segment your AI needs based on things like data sensitivity, need for customization, strategic importance, and then apply the right strategy, build, or buy to each segment.
That's the essence of the hybrid approach. And the source points out that this is often supported by those complementary technologies we discussed earlier.
Like array and vector databases.
Exactly. Those tools are vital building blocks, whether you're ultimately sending the retrieved context to an external API or to your own internal model. They work across the hybrid stack.
Because the retrieval happens first in your controlled environment before the data even goes to the language model.
Right. RA lets you inject specific, timely knowledge without necessarily having to fine-tune the model itself on everything. Though often, RA and fine-tuning are used together for the best results. And observability tools also become super important in a hybrid world.
Observability, meaning monitoring.
Yeah, but more comprehensive. If you have some AI tasks running on external APIs and others running on your own internal models, you need a way to track performance, latency, costs, error rates, usage patterns across that entire distributed system. You need unified visibility.
To see what's working, what's breaking, what's costing too much, regardless of where it's running.
You got it. Managing a hybrid AI stack effectively requires good tooling for monitoring and orchestration. The source gives that finance company example, which really clarifies the hybrid model.
Right. Finance, another industry where data sensitivity and regulation are paramount.
Totally. So the example describes a finance firm routing, maybe, 80% of its general AI traffic, things like summarizing market news feeds, drafting internal reports from public data to cost-effective hosted models via API. Speed and breadth are fine there.
But for the critical 20%.
The workflows involving sensitive client financial data, trading algorithms, compliance checks, that remaining 20% run strictly on in-house LLMs. Models they control, likely fine-tuned on their proprietary data, running securely inside their network perimeter.
So they get the best of both worlds, API convenience for the bulk and build host control for the critical regulated parts.
Exactly. They strategically balance cost, speed, scalability, control, and compliance by not forcing a single solution on every problem. They use the right tool for the right job.
That feels much more realistic and achievable for many organizations.
It is. It moves away from a potentially paralyzing binary choice towards a more nuanced, pragmatic strategy. You figure out when to buy, when to build or host, and how to make them work together effectively.
Okay, so if hybrid is often the way to go, and you need to make these decisions use case by use case, how do you actually decide for a specific AI feature or application? The sources offered some guiding questions, right? A kind of decision framework.
Yes, absolutely. A really practical set of questions to ask yourself, acting like a filter to guide you towards build, buy, or blend for that specific situation. The first, and maybe the most crucial one, is this core to our business pick?
Why start there?
Because if the AI capability you're considering is your secret sauce, your primary differentiator, the thing that makes customers choose you over competitors, or if it's deeply intertwined with your valuable intellectual property, you probably need to own it.
You don't outsource your core competitive advantage.
Generally, no. Building gives you the control to innovate on that core capability, protect it, and keep it unique. If it's more of a supporting function, maybe buying is fine. But if it is the business, you lean towards build.
Okay, strategic importance first. Next question. Will costs scale linearly with user growth?
This forces that hard look at the long-term financials. API costs, being usage-based, tend to scale up directly as more people use your feature. Great at the start, potentially ruinous at scale.
Whereas building has high upfront costs, but potentially lower costs per user once you hit scale.
Exactly. Building might have a much lower marginal cost per query after the initial investment. So you need to model your expected growth. At what point does the total cost of buying overtake the amortized cost of building and running it yourself? It's a break-even analysis.
Makes sense. Question 3 brings back a critical point. Are we handling sensitive or regulated data?
And this can often be a showstopper for the buy path, or at least the standard API path. If you're dealing with PII, PHI, financial data, anything under GDPR, IPA, etc., compliance is king.
Sending that data out might just be forbidden.
Often, yes. Unless the API provider offers very specific, sometimes costly compliant environments, like HIPAA-compliant endpoints, keeping the data and the processing entirely within your own secure, auditable systems via building or self-hosting is frequently the only permissible way. Compliance often forces your hand towards build host.
Okay. Question 4. Do we need to customize responses or behavior deeply?
This gets at that need for specialization. Does the AI need to speak fluent your industries? Does it need a very specific personality or brand voice? Does it need near-perfect accuracy on a very narrow task that generic models struggle with?
If the answer is yes,
Then you likely need the deep control over training data and potentially model architecture that comes with fine-tuning or building. Buying a general API gives you general results. Building lets you craft a specialist.
if good enough isn't good enough, you build. Okay, question 5 is that all-important reality check. Can we support the infra and talent to do this well?
Yeah, time for brutal honesty. Do we actually have the ML engineers, the MLO skills, the infrastructure team comfortable with GPUs, and the budget not just to launch this, but to operate it reliably, securely, and efficiently over time?
Can we handle the pager duty, the debugging, the updates, the scaling?
Exactly. As the source said, owning models is different from owning API keys. If you don't have the internal muscle or a realistic plan to build it, trying to build might just lead to an expensive failure. Your capabilities have to match your ambitions.
Be realistic about your resources. Okay, and the last question. What's our fallback plan if pricing or access changes?
This tackles that vendor lock-in risk head-on. If you do rely heavily on a third-party API for something important, what's plan B?
What if they jack up prices by 10x? Or discontinue the model version you depend on?
Right. Do you have an alternative provider you could switch to relatively easily? Could you pivot to an open-source model running internally if push came to shove? Thinking about a fallback forces you to design for resilience and maintain some degree of strategic flexibility, even if you choose to buy initially. Don't paint yourself into a corner.
Wow. Those 6 questions really cover the key dimensions: strategy, cost, compliance, customization, capability, and risk. A solid framework.
Definitely. They help structure that complex decision. And the source kind of boils down the core intent behind the two main paths very neatly. Build strategic investment, whereas buy equals fast access.
Build is playing the long game, investing in a core asset. Buy is getting speed and functionality now.
That's the essence. And the overarching advice woven through all of this is to choose intentionally. Don't just drift into buying because it seems easy today, or jump into building just because you want control without considering all the angles. Make a conscious choice based on a clear understanding of the requirements, your capabilities, and your long-term goals for that specific use case.
This has been incredibly clarifying. It's so clear from everything we've discussed based on the sources that this isn't some simple choice. In today's AI world, it's definitely not just build or buy for everything.
No, absolutely not. The smart play, the effective strategy that the material points towards, is really about understanding the trade-offs deeply. Knowing when the speed and simplicity of buying makes sense, knowing when the control, customization, and compliance of building or self-hosting are essential, and crucially, knowing how to blend these approaches intelligently across your business.
And making sure those choices align with your bigger picture, right? How does this help defend your product in the market long term? And does your team actually have the chops to execute the chosen strategy?
Exactly. It demands that realistic self-assessment alongside the strategic vision. You need an AI stack that's not just powerful today, but also adaptable and sustainable as the technology continues its relentless evolution.
Which leads us perfectly to that final, really potent thought from the source material. It's a great takeaway message.
Yeah, it really reframes the whole decision. It says, the best choice isn't what's easiest today. It's what makes your AI stack scalable, sustainable, and smart in 12 months.
Scalable, sustainable, and smart in 12 months. That forces you to look beyond the immediate convenience or the immediate challenge.
Right. The path of least resistance now might lead to a dead end, later crippling costs, lack of flexibility, falling behind competitors. The harder path up front, the strategic investment in building capability or carefully choosing hybrid approaches, might be what sets you up for real, lasting advantage down the road. It's about strategic foresight.
That's definitely something for everyone listening to chew on. What does scalable, sustainable, and smart mean for the AI you're involved with or the AI you're thinking about using? How do these principles of build, buy, and blend map onto your own world?
It applies everywhere, really, from the giant enterprise figuring out its foundation model strategy, right down to the startup adding its first AI feature. Those core questions, control, cost, speed, data, talent, they always apply.
Absolutely. Well, this has been a fantastic deep dive. Thank you for walking us through the source material on this critical AI build versus buy strategy. It's complex, it's evolving, but hopefully this discussion has given you, our listeners, a much clearer map of the territory and some solid questions to ask as you navigate it.